Hey everybody, good to see you back once again. The engine side panel build continues and we're just about to start on the upper half portions of each one. But first, I need to take a couple minutes to make sure everybody's fully up to speed as to what we're doing here, because over the last 2 episodes I've had probably 20 people now ask pretty much the same question, and that is, why are the panels that you've made to this point not as tall as the yellow ones? So I'll take the rap for that, because I have an absolutely clear mental image as to what everything is going to look like, how it goes together, and how it's supposed to be. Sometimes I don't always fully articulate enough details to get everybody pretty much to the same place as I am. So we'll start from the beginning. We'll try and keep it brief. What we're doing is replicating front-mounted factory option components for an early Caterpillar D2. These early D2s did not have a structural radiator shell that front-mounted components could attach to. Pretty much it's just stamped tin with a core that's secured inside, and it can support light brackets, but that's about it. So the later D2s had a fully cast iron radiator surround and heavy duty. It was a structural component, had all the mounting holes already drilled and tapped, front, sides, everywhere. So if you needed to throw a grill guard or a bumper on, you just bolted right to that. These early ones, you can't do that. So if you're going to put front mounted equipment on, you need to provide additional bracketry that gives you the structure to hold those pieces. And what we're trying to do is replicate pretty much what's on the D2 in this archive photo, except for that grill guard. We don't need that, but we've got the belly pan going on, we got the front tow hook going on, and right now we're working on that curved front bumper. That is a pretty rare option to see on D2s. I've never actually seen one in the flesh, and this one that I'm making is going to be the closest thing to it. So to do that, well, I've shown this parts manual diagram before. Here's the side view of it. These are the side irons that we made first. Those were the pieces that were from my grandpa's old cat that were in just poor enough condition that they would stand in as excellent patterns to make new ones. So we've got that done. But when you use those side irons, you can't use the standard one-piece engine side panels, because this portion up here blocks access to the area of the radiator support where the side iron mounting brackets need to attach. So Cat had a problem on their hands. They could have still used a slightly redesigned one-piece engine side panel. The problem is it tucks behind these side irons to the point that if you needed to remove panels to perform maintenance on the tractor, you'd have to remove the side irons, which means you'd also be removing whatever happened to be mounted on the side irons as well. That was going to be a lot of work that nobody was going to want to have to do. So their solution to that problem was to make the split two-piece engine side panel. So we've got the lower portion made. You can see that tucked behind the iron in this picture right here. Upper portion hooks behind the lower portion and then has another 2 bolts in each top corner holding in place. So that's what we've got right here. Again, this was the one other existing piece from my grandpa's cat that I could use for dimensions. If it wasn't for this piece right here, this whole project would have been a lot more difficult. So when you couple the lower portion that we already have with the upper portions that we're about to make, you end up with an engine side panel that basically does the same job as this one piece. It just makes life a lot easier when you have side irons and front mounted equipment. And you can see where once the top portion is removed, you've got full access to everything you could possibly need to work on both sides of the tractor. So that's the reason why we're making panels that are shorter than the originals, but we need to use the original ones for like the bottom edge contours and gusset shapes and everything like that. And then we blend it with the existing top portion to figure out spacing and height and distances where the split line is. Well, I shouldn't say long story short, that was still a long story, but hopefully that gets everybody perfectly up to speed with exactly what we're doing and what the plan is moving forward. Let's get busy now. Now, I've already got both of the starter blanks cut out. This is the same 14 gauge steel. We are doing the standard 40 1/2 long, and I made these 8 inches wide to start with. Measuring our existing original, in a perfect world, I could get by with 7 5/8. I gave myself 8 because I like to have a little bit of breathing room, especially because we're going to be rolling the top edge as well as an offset in the bottom. So first thing I'm going to do is fold over this whole top edge. We're not worried about this tube that's welded for reinforcement, but I need to get a pretty tight bend on that upper portion. That's about 5/8 of an inch wide. And if I had a tipping die, I'd be using the bead roller. I don't have a tipping die to fit that one. And this 14 gauge is pretty easily hammered, so I'm going to take these out to the big metal table, and I'm just going to hammer and dolly those over. We're going to do that manually to start with. All right, took a couple minutes, got it clamped down to the table. That is a perfect heavy-duty straight edge down there. Backed it up on top with some angle iron and another heavy piece of about 3/4 steel. Clamped it all in place, clamped some backstops to help prevent it from shooting that way. And I've got a whole drawer full of body hammers and dollies. But just for bulwark like this, I like a heavy ball peen and this old section of rail. I like the width of the base of it because I can, you know, hammer on it like that, and it doesn't leave like any sharp imprints or marks in the steel. So works pretty good. I'm about halfway there right now. We'll get back here so it's not so much glare. You can see we're about a 45 on there now, if we can sight past that clamp. So another reason why I like to use this railroad iron kind of as a wider striking surface. See, in this case, the table's like the dolly. Okay, that's backing us up. This is just an intermediary between the steel and the hammer, and I like that nice wide bottom on it because as I'm striking, it's spreading that force out over a wider area. If I were just to use the end of the hammer and be concentrating my blows in small circles like that, small areas, if I bent any one small short section over more than the steel on either side of it, that's actually going to stretch the metal that we're forming on this lip here. And if you stretch it in enough places all along and you don't just work it over continuously and evenly, think of it as like, you know, it's fanning out just on this small bend because you've made that metal thinner and it's going to want to take up a wider area. So when you get done and everything's all 90 degrees, you take these clamps off of there, and then all of a sudden your panel's going to have a bow in it because this lip you hammered is basically going to be longer than the rest of the flat that's at a 90 degree to it, if that makes any sense. So working it over with a wide base, little by little, keeping it all even, it's going to be square yet after we take the pressure off. A table edge does a pretty good job. I've used that before. And ×2, and we have the upper edge profile of each panel complete. It's amazing how much more rigidity just a single 90 degree bend puts in these panels. They don't flop at all. Without that in place, they flop really easy. So the next step is to roll in this bump in that goes all along the bottom. That's where the upper panel has to dive in and tuck behind the lower panel. I am going to use the bead roller for that. I had to make a custom set of rolling dies though, right here, because anything I already had for this old Pexto is all this round ring stuff. And instead of trying to find an already made set of dies that would fit it, well, I had this 2 3/4 round stock on hand already, made for the perfect working material to turn out a couple of custom dies. I needed the 1/8 step with the 3/8 gap between. Should give me the proper offset that I need. And when you make rolling dies, you always want to taper the outside edges. You only want to have a sharp edge here and there. That's because when you throw that piece of metal in between, those two steps are going to want to be twisting it in there, and it's going to want to put pressure on the outside edges of each one. You don't want to have track marks out there where sharp edges would be going, well, 3/4 of an inch outside of where you're actually trying to form it. So those are just mild steel. Typically rolling dies are hard as can be. I've only got about 81 inches total of panel that I have to do. They should last long enough to pull that off. All right, Senior's gonna crank. I'm gonna guide the piece because it's such a long run. Oh, there we go.
Tell me if you want slower or faster.
That's just about right so far. Slow's a little bit better, it's easier to control. We'll do multiple passes on this just like I did with the practice piece too. And once again, ×2, we've got both of the panels rolled. Perfect offset down there. You'll have to look in the light where it's reflecting. The camera is not really good at picking up the total depth, the offset, but when you throw that light up and down, you can really see. And the reason why we did that, I'll show you. So here's another piece of the same thickness metal, and we'll put that up on top and the straight edge on that. You can see we bridge, there we are, stand on its own. We bridge the gap so we have a perfectly level surface. The panel is going to tuck perfectly in behind the one that it's clipping onto. So that's the perfect offset. The dies worked just like they should. Now on each end, I had to dolly that bend back out because we're just replicating the way it is on this one. You can see our cutout right here only goes to that first bend, and then we have the offset and the second bend comes up above, but we need a flat surface on each end so that the panel can bolt flat against the bell housing and the radiator frame. So yeah, we dollied the bump out or the bend out so we're back flat on each end. You can also see my dies still left some track marks. You can see them, and they look a lot worse than they are. I can't even catch them with my fingernail, but you throw some paint on that, that's going to take those right away. If we would have been working aluminum, something softer, that would have given us some really big problems right now, but the steel's pretty forgiving. So next step is to pop the mounting holes, the bolt holes. I've got them all center punched out. We'll get that done real quick. All right, we're at the point where we can try our first test fit. See if we've wandered off course or not. Started in with the clips. That one hooked well. Good there. Looking good there. Let's see if we can start some bolts. Yep. Good friction. Okay. Run this one the rest of the way and take the bang out of it. So far so good. Let me get you off this pole. Good clearance right there. I like our gap, perfect standoff where we tuck in behind. Good clearance right here. Fitting well. And just barely clears the hour meter. That's normal. The fuel injection pump, or the fuel transfer pump, I should say, sorry, that's where it gets really tight tolerance, because this upper curled over lip literally has to be between these top two bolts and then the bottom two. But we're good, not contacting anything. So we can take it back out, move on. And this really shows why these two-piece side panels are so convenient. Two top bolts, and it just unclips just like that. Opens it right back up again. Forming the bump in for the starting engine drain tube on the right side panel right now. Same forming jig, forming die as I used on the lower half panel 2 episodes back, so we're not going to get too into detail on it. In case you did not see that episode, go 2 episodes back. I'll tell you all about it. So let's just get it done. Hope we don't blast the panel out now. I feel like I should have stopped at that last one. Little devil on my shoulder says, go for one more. Try and concentrate the heat where I'm going to need it the most. We call that good. And good news, after all the work to this point, we didn't blast the panel out. That is a bit of a relief. So that bump in looks really good. Backside view, really good. So you can tell we're starting to take the shape of the factory original. And tell you what, let's just check our spacing on that, make sure we located it properly. We're not going to tuck it back behind because we still contact that oil filter can. We haven't put that bump out in it yet, but we line up the old witness mark. There's where the old panel was. Yeah, spacing on that is just where it needs to be. So we're good up to this point. You also may have noticed where I replicated the cutouts on the bottom corners. We cut this one back a lot further than the panel that was off of my grandpa's old cat. That's because 1113 here has this first generation oil cooler that has the tap that comes out right here. My grandpa's old cat did not have that. It had the next series newer oil cooler. These taps were not present there or up there. So that's why they got by with the standard cutout on the front of that one. We need more space on this because we don't have room for panel behind panel right there. It would contact that fitting. So that's a first generation detail right there. So the next feature we're going to have to put into this panel is this bump out that we were just talking about for that oil filter can. You can see how that is going to be necessary to clear. And that's going to be a little bit more fun. I'm no doubt going to have to make another forming die to provide the support back here, something that's shaped properly to apply force from the inside. I've been looking more and more at this panel because it doesn't have 15 layers of dead paint on it. You see a lot more definition. So we're going to look in the light, see if we can see witness marks from like the support die in the back. Check out beneath this welded stiffener tube what the contour was of their die that went in there. And I'm pretty sure I can replicate that. I'm telling you right now, I don't want to have to do any cutting, welding. I don't want to have to make any slits. I want to form this panel one piece with this top rolled edge, just like it is now. And I think I can do it. But I'm going to have to put the old thinking cap on to do that. So yeah, we're not going to get to that part in this episode here, but everything we've done on these upper half panels has went very well. The rolling I was kind of nervous about with Senior helping out, turning the crank. I could just guide the panels. It went just perfect. So, all right, hopefully everybody now is up to speed on exactly what we're doing. Yeah, we're just taking what's left of existing original option pieces, working in conjunction with this diagram I've showed about 3 times now. We're building this right here. This is what we're doing. I'm not conjuring this out of my imagination. We're just replicating Cat Factory options, so this is not even my design. We're just going back to the original drawings. So, test on it tomorrow, right? Thanks for watching, everybody. I'm going to get cooking on a new forming die. Might do a couple practice pieces, and then if I'm happy with the performance or if I find I can do it, we'll pick back up. Thanks for watching.